Welcome back everybody to the next episode of building this reactor. I know it's been a little bit. I really been working on this thing non-stop. My heart and my soul put in this. I wanted to show you guys I've been having some leaking problems with these waveguides, so I put this little homemade silicone ring around that. Now I also wanted to show you how I'm sealing the shaft. So basically, I don't know if you can see in there, but I have a ring in there. It's called a packing ring, and it looks pretty much like this right here. And this is basically PTFE and fiberglass, a fiberglass and PTFE ring or Teflon ring put together. Really slick, low friction, and it goes in there and it seals it under compression, especially with some oil put in there. So with that being said, I wanted to go ahead and get this old paint job off and go ahead and get a new paint job on, because it's time for some new energy in here, guys. And you know, I won't lie to you guys, honestly, the curve of this barrel made sanding off this old paint an absolute pain in my tits. So I said, F it, I'm just gonna put the primer and the new paint right over it. Now I know it's not the best idea, but honestly, I know this won't be getting all that hot because microwaves heat the material, not the actual reactor that much. So put the primer on, and we started to put this actual paint on. And a little story about this paint: I ordered a darker paint because I like dark green more than light green, but it said it was undeliverable like the day it was supposed to show up. So then this was the only other green that I could get that was a good, solid, high temperature, strong industrial green. So I mean, actually, in my opinion, it ended up looking pretty good. Like, look at it, you know, with the silver accents, it looks quite well, guys, in my opinion, of course. So you see, we got the black on the handle here, and everything else is like silver. The stand itself is black as well, but overall, it just looks really good if you ask me, honestly. So I took some body panels off of an oven, and I started to put together this little electronics box here, because of course, as necessary as the reactor is also necessary what to power it with, right? The actual powering system. So I had to take the time to do all these little shimmy cuts. I got a Dremel for it because honestly, man, in my previous reactor I did it with little aviator snips, and it was Brexit squares and stuff. So I was like, okay, let me do it with the Dremel. As you see, it's turning out well. Had so many dang cuts to make for all these switches and the fans and everything. And you know, the Dremel, it worked, but it took a long time. And as you see, we got it. So excellent. I know what you're thinking. Ah! Jab! It's an orgy of switches. It's an orgy of switches. What is this? Why are there 10 switches? Listen, every single transformer is going to be on its own circuit, so I can turn it off and on individually. Every single fan to every single transformer is on its own circuit, so I can turn it on and off individually. And on top of that, there's fans like this fan in here.
I didn't understand that.
What the? Shut up! Alexa? Or whatever the hell that thing is. Bixby? Oh, look. Anyway. What the? Alright. The fans in here. The fans in here are on their own circuit as well. And on top of that, the light that goes to the reactor itself is going to be on its own circuit. So all that will come out to equal 10 different circuits, which is why I need 10 different switches. Simple. I also wanted to let everybody know that I've learned a lot from my mistakes. The biggest reason why the reactor exploded last episode is because it was never airtight. So when I went to push the oxygen out with the flammable gas, instead of it pushing the oxygen out, it would just be leaking. And it was actually leaking at all these magnetron ports. And that's because the fiberglass blanket I put between the magnetron and the waveguide system that I showed in like the last episode or whatever, that does not work. I needed a different type of fiberglass, one that is better woven. The fiberglass I used before just let air pass right through it. But let me show you guys now that we have this thing airtight for sure, and I know it is. So I have this plumbing system here, and this is a water bubbler at the end here, right? Water bubbler, all these filters, blah blah blah. I also have this line here which just has this hose. This is normally where I push in the pyrolysis gas right now. I just have this hose because I actually am going to blow air in here, and then if we can get the air to come out this other end, that means it's airtight. And I know that because the water bubbler actually needs quite a bit of pressure before air will come out. So if there's any leaks, it's going to leak before it will come out this water bubbler. So let me go ahead and open this valve here and show you it's airtight. So I'm just going to take this hose and blow on it now and watch. You hear that? It takes a lot of pressure. I gotta really take a breath to do that. So of course you can't really see it or feel it. All you can do is hear it. See, thing I have here, I didn't really show that much on how I built it. I kind of just put it together, honestly. We'll save that for the tutorial series, but combining that with grease and the packing rings, the stuffing or whatever you want to call it, the packing. I mean, this thing, like, it's compressed on there so much that it, like, I couldn't see how air could get through there, especially with grease. But the good thing is, even if it were to have too much oxygen in it with this water bubbler, it would pretty much be a flashback arrestor, and then these filters actually have steel wool in them, which is a filter, but also a flashback arrestor as well. So, this thing most likely will never explode like it did before. I learned so much. The only way this thing can explode now is if we have all 5 magnetrons on and this blade spinning, and it's creating so much vapor. It's breaking down the plastic so fast that there's so much vapor formed that it just can't all get through here at once, and it has to explode. But that's very unlikely because this barrel can hold up to at least 5 psi, and even with a crazy amount of vapor formation, I doubt we're going to have 5 psi in there. Alright, I just finished one of the major first steps in circuitry, and that is all of this beginning stuff. And I know what you're thinking, shut up! Oh, Jeb, it's an orgy of cables! Yes, it's an orgy of cables, okay? This is 11, 12 different circuits, all from the same power supply. So I'd like to see you try to make that not an orgy. That's pretty much impossible. That's like asking Blue's Clues to be a Blood instead of a Crip, okay? It's not happening. But I do have all these wire nuts, and they certainly help it a lot, because even though it's an orgy of cables, it's an organized orgy. All these cables, all these switches at the bottom, there are 5 of them. We represent the transformers and the magnetrons. 5 switches, 5 magnetrons. So every single magnetron transformer on its own switch. Blah, blah, blah. Now, at the top, there are 5 of these switches as well. Now, there's going to be a total of 4 fans to blow air on the magnetrons, right? Because we don't need 5 fans, we only need 4. As well as this internal fan here, and also the light that's going to, light up the system. But anyways, with that being said, I have a 50 amp circuit, and just these 5 transformers alone all at once probably would take about 50 amps. So I may not be able to power the magnetrons and the fans on just the same 220 line alone, but as you know, you need fans for the magnetrons or they're going to die. So anyway, I have this right here. So I can plug in a standard 120 line, and then I can basically have the fans run off of either the 220 line or the 120 line if I wanted to, right? Like, let's say I don't have all 5 magnetrons on, I just have 4. Well, then I can probably have the fans running on the 220. But if I have all 5 on, right, I have too much power for it all to be going through this one cable, right? That's going to be like almost 55 amps for a 50 amp cable. So I'd rather just plug this in and have probably that's like 5 amps or so worth of fans come on here, switch this switch on, and then it'll be running off a 220. And then this is just going to be the switch for flipping it between the 220 line or not, right? So once again, this is regular power from the wall, and then this would be for the big power if I want the fans to run off of that. And that is why there's an orgy of cables. It is looking good, guys. As you can see, a fat horse cock of a cable right there. It's put this electricity in here. We have this meter here. This actually will read out the electricity being generated, as well as some other things. Like, for example, it says right now it's at 118 volts, 60 hertz, you know, and then it tells you the energy consumption. Tons of cables in here. I'll do my best to organize it, but honestly, there's only so much you can do when you have this type of space and you don't have like prefabricated channels, so it's not really my priority. Every single transformer is on its own circuit. This system here, between switching from regular 120 wall power or the 220 to power like the fans, it works great. As you can see, I have a little small fan there just to test this out. So I turn this, let's turn this flip on. This is going to be the 220 side or the 50 amp circuit. And then I believe the fan switch is this one. I'll have labels for all these switches. Yeah, as you see, the fan is on now. And then the magnetrons, let's see, I'll turn just one on. You hear that? It's on. And then I could turn, that was the first one, and I could turn the last one on here, which is going to be that one right there. Yeah. So, works great, honestly. It's looking really good. I got all the receptacles wired in, so we're on the last couple steps. What's up, guys? So this is the power supply, all put together, all wired up beautifully. 220 volts come in, but I'm only using one of the hot wires, so it actually ends up being just 120 volts. 50 amp power cord, because every white microwave system pulls about 10 amps, so 5 of them equals 50. Now this works. I have all these switches because everything is on its own circuit. All the fans, all the magnetrons, the lights, every single thing on this reactor is on its own circuit, right? So let me show you, for example. There's an internal fan that just blows air, cools all the capacitors off. Turn this switch on. And I use this piece of wood because I'm terrified of electricity, honestly. Even though this whole thing is like grounded 30 times over, I'm still scared it's going to shock me. So anyway, that internal fan turns on. Let's see, if I flip this switch, one of the microwave fans will turn on. Yep. Then if I flip this switch, this transformer will turn on. This bottom switch here. So, as you see, everything is on its own switch, everything is on its own circuit. And that's basically the safest way to do this, because I don't ever need to have like all 5 on at once or whatever, you know what I'm saying? Like I have ultimate control over everything. So, that's the great thing about this system. And it works really well. Nothing is arcing, nothing is sparking. Of course, the longevity is the real test. I have all of the transformers coming out of these 30 amp 220 volt receptacles. I know that it's 4,000 volts DC, but these have worked in the past for me and they're working again now. They just screw in here with these this receptacle here, and it just goes in. Once again, I have everything like double grounded. I don't have every single magnetron grounded because every single magnetron does not need to be grounded. I only have 2 grounded, but even the cords are not grounded. I have a ground in them that just goes onto this, so that way this whole outside sheath cover is grounded. So basically, if there's ever a short circuit in here, it's never going to hit me. It's always just going to arc onto some type of metal. There's nowhere, anywhere in this whole thing that is not grounded, because I'm terrified of this much electricity. And yeah, it's that simple. So that's the circuitry system. Great. So right now I just have 3 magnetrons on, just as a little test run to see what's up. And you know, it didn't blow up again, but we do have some issues. So the actual control panel system is working amazing. Our biggest issue lies in all of this. As you can see, this rotating shaft is leaking, as well as some points back here where I had welded and cut away brackets. Another point that's leaking is this very edge corner of this this window. Another point it's leaking is where the light goes in, but I think that just needs to have some more thread sealant put on it. Another point that's leaking is back there behind the waveguide. So I guess the fiberglass needs to be put on there again. So we do have quite a bit of leaks. Even small insignificant leaks become quite large under this much pressure, I guess. Seems like there's another leak down here. I don't exactly see where it's coming from, but I see the gas is coming out. So this is quite crazy. I mean, there's literally leaks everywhere. And the gas does come out of this system. I'll take this off to show you. As you can see, quite a lot of it and quite a lot of pressure coming off of this. So there's absolute tons of gas production. Just 3 magnetrons in there. And a lot of pressure, obviously, and that's why we have all these leaks everywhere, which are unacceptable, of course. But at least the electronics part of this stuff is down. But now is making it airtight. That's the hardest part. Of course, I can seal any place I need to weld. That's not that hard. Sealing the shaft, I thought I did a good job with the packing. I'm not sure what more I could have done with that, so I don't know why that's even leaking. Under here, I guess this could be leaking from back when we had that whole explosion situation. It could have put some stress on the metal and created a gap somewhere under here. I don't see where it's leaking from under here, but all I see are the gases coming out from under here. So it's kind of weird. So I mean, that's where this thing is, guys. I mean, it works. It's really powerful. I mean, to have this much gas production this early with just 3 is crazy, but there's all these leaks that I gotta fix. So yeah, gotta do that. I swear, man, the worst things happen as soon as I turn the camera off. So unfortunately, shortly after I turned the camera off, I went to go give the agitator a spin, see how that would do. And every time it's agitated, the pressure builds up immensely. And it happens so quickly, the pressure builds up so quick that this thing, it exploded again. But this time, it was definitely a lot more of a bigger explosion. Well, not really. This actually wasn't that big of an explosion, but as you see, I mean, look at this aftermath here. It just is like, I guess all of the just all the power combined with the agitation is too much for a 55-gallon barrel. As we see, this is the lid. Just like the other lid, just absolutely destroyed. It's greenhouse. Goodness gracious. So what does this mean, really? To be honest with you, as much as I hate to say it because of how far we've come, this vessel, this 55-gallon drum is inadequate for the power we're putting in it. It's not gonna work. Maybe without agitation, this system works, but with agitation, with how much vapor it produces so quickly, it just can't hold up to the pressure. Something I didn't mention in my other video is the last time it exploded similarly was as soon as I moved the agitator. So you guys saw it was doing fine just on its own, but when the agitator moves and it just like releases all that gas, it gets trapped between the plastic immediately. It just is too much pressure. There was no oxygen in here, by the way. This time around, I made sure the oxygen was out. So it was not an oxygen explosion. And I know that because there wasn't any fireball. It was simply just a pressure explosion. So honestly, I mean, I hate to say it, but this is inadequate. This does not work. And there's not much more to say about it or do. It's a shame because we had all this stuff set up. Honestly, I don't even know where to go from here, to be honest with you. I mean, Goodness. Goodness gracious. Goodness me. Goodness me. Goodness me. Yeah. I guess that's it, really. I guess that's it. It did end up shooting a molten piece of plastic on the ground, like right behind me. Because obviously, when it exploded, I stepped back. I stepped right on it. Of course, me being barefoot, I burned the bottom of my foot pretty good. But that's pretty much it. I'm pretty good other than that. But honestly, guys, I mean, I don't even know where to go from here. I mean, like, I put all my money into this, so I don't even have money to build another reactor, really. Of course, the only other vessels I can think of is like a propane tank, some type of anything built to withstand pressure. It was always based on the premise, of course, this 55-gallon drum is never meant to be a pressure vessel. I know that, I'm not stupid, but I thought with pyrolysis we would never have that much pressure. You see what I'm saying? Because there's always an open port where the gas comes out. But it's something about the agitation, I'm telling you. It just does something crazy. I guess the best thing out of this is this power supply we made here. An absolute beast, and it works great. I mean, this thing wasn't failing at all. I did learn a lot of skills from this, a lot of new techniques in welding and putting stuff together. I can keep this same plumbing system. Man. Honestly, guys, I wonder if you have a horizontal reactor and you have many magnetrons, do you even need agitation? Because, even if the agitation had worked, we had a huge leak there. And I don't even know where I would start to solve that. So, I mean, maybe, perhaps, adding the agitation is a little bit above my pay grade. Nah, man. I mean, because even if we have a 55-gallon drum, agitation is still going to be an issue in terms of making it airtight, getting it there. Damn, y'all, I was just planning on live streaming this thing literally tomorrow. Live streaming it running for the first time, but even if I wanted to, I don't have another lid for this, and I'm not going to. It's not safe, obviously. It's just a damn shame, honestly. It was beautiful. It was beautiful. Some of my best work, I would say, but that wasn't enough to save it. So I guess this is a great lesson for all of you guys who may be wanting to build one of these. Don't use a 55-gallon drum. At least not with microwave pyrolysis. Maybe conventional, but microwave pyrolysis, the heating is too rapid and too extreme. I'm honestly lucky that I was far enough away from this thing when it did explode. And I was on the side of it. I'm not very embarrassed, but I'm kind of more just like sad, because it's like, dude, I've been wanting to get back into pyrolysis for so long. I haven't run a reactor and actually made fuel from plastic in like feels like a month now. It's only been like a couple weeks, and then I put all that work in here, blood, sweat, and tears for like 3 weeks straight. Like I've been working on this for months, so for the past 3 weeks it's just been non-stop, just day in, day out on this thing, just for that to happen. But I mean, I can't say that I can be mad at myself. I mean, be mad at the barrel. It was never made for this. It was never made for heat. Never made for pressure. I was just trying to take resources that everybody could have potential access to, and make it work. But the next best thing is a propane tank. It's right here. 20, what is this, 20 gallons, is this 40 gallon? We could take one of these, put it on its side, and we could mount up to 4 magnetrons in here. The hard part would be making a flange system for this. We're not going to use this one in particular, but you know what I'm saying, I'll get another one. Making a flange system for it, that's going to be the hard part. So that way it can be opened and closed to clean out the carbon. And it does already have a hole at the top, so that wouldn't be too difficult to add agitation. I suppose, I guess making the blade would be the hardest part, but I do already actually have a blade I already made. Remember this blade? This blade here is, I think it could fit in there. I think it could. At least some parts of it. I know it's a major scale down from where a 55-gallon drum, of course, but honestly, all I can do is scale down at this point, guys. Just to be honest with you, I certainly don't have the money to scale up right now, because I put all my money into the 55-gallon drum. It's like gambling, right? But I may actually be able to pull together enough resources and enough materials from what I already have just laying around to make like a small scale model out of this 55-gallon drum. We could put 4 magnetrons on it. Now that's going to be a stupid amount of power for this size, but at least this is rated for pressure, so it can actually handle it, right? We put a little agitation in there, and you know, it'll be a lot smaller. You know, it's not gonna be as large of a quantity, but I can guarantee it will work, and I can guarantee it's going to be a hell of a lot safer. I need to come up with an idea for a flange system for this, so give me some suggestions for that. I know we can cut around this base, right, and then add, like kind of make a flange system from scratch. You know what I'm saying? Like cut the base and then weld on like a plate around here, you know, circle on one side, circle on the other with holes drilled in it. That's pretty much all I'm thinking. A gasket in between it. That's pretty much as simple as we can get a flange system for this. But yeah, guys, it's an absolute shame that this reactor didn't work, but we gotta keep moving, you know. I can't let it slow down this project, because at the end of the day, if there's one thing that this showed, it showed that microwave pyrolysis is the shit, because for this thing to blow up, it had to be over like 10 psi of pressure so quickly. So that means that these microwaves can absolutely just obliterate plastic, which is amazing. It's just bad for a system not rated for that. So we're going to build a system that is rated for that. We're going to do it at a smaller scale first, so if something does go wrong, I don't literally destroy everything, destroy a 5-continent radius. The only thing that sucks the most is it's more building, it's more time. Now, I just labeled these magnetrons too. You know what I'm saying? Look at that. And what am I going to do with this? What am I going to do with this system? What am I going to throw it away? I don't even know what to do, guys, honestly. It's a big reset. It's like Thanos just snapped everything out of existence. I can't let it get to me, though. I can't let it get me down, though. I got to keep, you know what I'm saying? I got to stay motivated, you know, because at the end of the day, everything is about perspective. And I just see this as a necessary thing that had to happen. Because if I were to patent this design, make this design, and that's a potential risk, that's a horrible thing, you know, obviously. So I'm glad it happened early. I'm glad that we can see this. I'm sorry to all of you, because I know I pumped everybody up. I put so much faith in this, and it just wasn't it. You know, once again, I think that this does go to show my welds actually do hold up. None of my welds failed, despite the second explosion. None of my welds, the glass didn't even crack. None of the waveguides, nothing crazy. Literally, only the lid flew off. But yeah, guys, I'm sorry for letting you guys down. We just got to do this next thing. Keep it moving. Never give up. Yeah. Peace out, guys.